Today we're going to talk about what does it mean to be intrinsically safe. Now, intrinsically safe design is a protection technique that's applied to electrical and wiring products used in a hazardous location. In simple terms, intrinsically safe devices are limited in the amount of electrical and thermal output to prevent atmospheric ignition. Now, the reason why this becomes important to us is that intrinsically safe electronics must be used in hazardous work environments. But what exactly makes these places dangerous? OSHA defines a hazardous location as an area where flammable liquids, gases, or vapors, or combustible dust exist in sufficient quantities to produce an explosion or fire. In hazardous locations, especially specially designed equipment and in special installation techniques must be used to protect against the explosive and flammable potential of these substances. Now, people that work with these hazardous locations are at a reasonable risk of explosion. There's a certain number of occasions when we as a company get involved in situations where this is a real possibility. So there is the risk of explosion, injuries, death, or environmental damage, and therefore they're subject to GHS and intrinsic safety regulations. Now, the intrinsic safety industries include any business that manufactures, processes, or ships chemicals, oils, and natural gas, mining, and fine powdered foods, as well as any facility where flammable substances are produced, mixed, distributed, or stored. So if a company uses potential hazards in their everyday operations, then they would also qualify. So how are we going to successfully eliminate the risk here? While the chance of an explosion or fire can be mitigated through various physical deterrence and safety measures, the risk increases exponentially when electrical devices are exposed to any of these combustible substances. In a world that's so heavily run by computers, this understandably complicates a lot of industries. Imagine if, for example, miners weren't allowed to use a flashlight without fear of setting off flammable gas. Obviously, most modern companies need electrical equipment to run their day-to-day operations. But how can they be certain, or how can we be certain, that our workers are going to be safe? Well, let's first talk about device separation. That's really the first line of defense. Preventing a potential explosion begins by keeping hazardous products and materials separated from non-compliant hardware. By cutting off the problem at its source, you can eliminate the risk of explosion altogether or isolate it from the majority of workers. Strategies for isolation include switching hazardous materials for non-hazardous substitutes, installing secure blast doors, utilizing safety kill switches, or redesigning the work process. When a hazardous substance or piece of electrical equipment cannot be removed or separated from the work site, this is when a specialized intrinsically safe hardware comes into play. So let's talk about intrinsically safe devices, essential protection for dangerous environments. Ensuring workplace safety in hazardous environments requires the right equipment. Electrical devices must conform to exceptionally strict standards. Typically, most electrical equipment will create small internal arcs or sparks as they run. You can look inside a mag drill and you can see the sparks as a mag drill is running. Compact electrical devices such as phones, tablets, and flashlights can generate heat with prolonged use. Now, during everyday use, these occurrences of heat radiation and small sparks are normal and harmless, but on work sites surrounded with combustible substances, they can easily become an ignition source and a catalyst for an explosion. When an overheated screen, faulty wiring, or single spark can devastate a hazardous work environment, compliant product design is imperative for workplace safety. So to be intrinsically safe, an electrical device must be able to operate without outputting too much energy in these types of hazardous areas. To limit the probability of ignition, intrinsically safe equipment, especially Class 1, Division 1 rated products, run on simplified, low current, low voltage signal and control circuits. Electrical currents lessened by using multiple series resistors and voltage is lowered through the use of several Zener devices to ground. So sometimes a galvanic isolation barrier is used instead to keep components separated from each other. Whatever barrier ends up in the design, certification standards for hazard-safe products typically require that it remain with approved levels of voltage and current so that no excess energy can be stored. Now, with regard to class and division ratings for hazard-safe products, hazardous work environments are separated into classes and divisions, categories that define the level of safety features necessary for any device that's used or installed in this location. While the type of protection required will depend on the specific risks of the area, as a general rule, Class 1 Division 1 hardware is recognized as the most compliant with worldwide standards. Now, you might not think that this matters. However, there are jobs in which we are involved periodically which have this kind of environment. So when you get into any job where there's a lot of tanks, there's a lot of piping, there's a lot of electrical equipment, there's a lot of gas or gases being passed around, these are the questions you need to ask before you actually start into work. Now, hopefully, we've gone ahead of you and answered these questions ahead of time. We've got the right equipment for you. But it's always good to ask the question, is this an environment? If you think it's an environment that involves hazardous substances or something where there's a potential explosion, you want to ask the question, do I need to have intrinsically safe equipment in order to operate in this environment?